Hi, hello dear students. Welcome to our channel Maths with Panindra. Now we are going to discuss about definite integration, limit integration as limit of sum. This is the second video. Exercise 7B questions, example 3 questions and the concept we discussed in the last video. And exercise 7B from question number 8 to question number 15. All the questions I am explaining here. Listen carefully. We may expect in the MCET exam also this question. In MCET guarantee question, one will be there in the either TS or AP. This type of question. In JMNs we can expect. Let us have a discussion the question here. Evaluate limit n tends to infinity root n plus 1 plus root n plus 2 plus and so on root n plus n by n root n. First, the given limit you have to write in the form of limit n tends to infinity 1 by n. After that, some other value. So, 1 by n, here n is there, no? That we can write it as the given limit. Limit n tends to infinity 1 by n. So, the rest of the terms, observe carefully. Root n plus 1 plus root n plus 2 plus root n plus 3, just I am writing, plus and so on root n plus n divided by root n. Later on, limit n tends to infinity 1 by n. So, root n plus 1 by root n. So, we can write it as root a by root b means root a by b. So, root n plus 1 divided by n plus second term root n plus 2 by root n plus 2 divided by n plus root n plus 3 divided by n plus and so on root n plus n divided by n. I hope everyone understand. Now, limit n tends to infinity 1 by n. We can write it as the first term n by n is 1 plus 1 by n plus square root of n by n is 1 plus 2 by n plus square root of n by n is 1 plus 3 by n. Plus and so on, square root of n by n is 1. Sir, why you are not writing here n by 1 by n by n is 1? So here the last term n by n. Here even that also 1. But observe carefully 1 by n, 2 by n and so on. I want to write this as sigma form. So summation. Limit n tends to infinity 1 by n. This we can write it as sigma I is equal to 1 to n root over 1 plus I by n. Am I right? Once check that I is equal to 1 substitute root 1 plus 1 by n. Sigma means plus. I is equal to 2 substitute 1 plus 2 by n and so on. After that what we have to do? I by n is equal to x. And in place of 1 by n dx, later on, limit n tends to infinity, sigma I is equal to 1 to n, we can write as definite integration with limits. That limits how to calculate? Lower limit and upper limit. Lower limit equal to limit n tends to infinity, total number is n. What is the initial value of I? Initial value of I is what? 1. As n tends to infinity, 1 by n tends to what? 0. Upper limit, n tends to limit n tends to infinity. Final value of I, n by total values, n is equal to n by n is 1. Limit of n tends to infinity constant is constant. So, in place of limit n tends to infinity, sigma I equal to 1 to n, replace with integral 0 to 1 upper limit to lower limit to upper limit. In place of 1 by n dx, in place of I by n x, so root over 1 plus x. I hope everyone understand. After that, integral 0 to 1 root 1 plus x dx. We have formula in integration. Integral root x dx equal to 2 by 3 x power 3 by 2. This is the formula for integration. This is indefinite integration. That's the reason. Formula no. That's why I kept C. But here it is a definite integration. Here we won't get C. Just apply the limits. So integral root 1 plus x value is 2 by 3 1 plus x whole power 3 by 2. Applying the limits 0 to 1, which is equal to 2 by 3. X is equal to 1, upper limit substitute. 1 plus 1 whole power 3 by 2 minus 1 plus 0 whole power 3 by 2, which is equal to 2 by 3, 2 power 3 by 2 minus 1 power 3 by 2. So 1 power 3 by 2 is 1. 2 power 3 by 2 is x power 3 by 2 equal to x root x. So x power 1, root x power is what? Root x can be x power 1 by 2. 1 by 2 plus 1 is 3 by 2. So we can write it as 2 by 3 into 2 root 2 minus 1 power 3 by 2 is 1. So this is the required value. So limit n tends to infinity, the given value is equal to 2 by 3 times of 2 root 2 minus 1. Now come to the question. And in the question number 9. Evaluate limit n tends to infinity 1 by n plus 1 plus 1 by n plus 2 plus and so on plus 1 by 6n. Here not n terms, 6n terms only there. So how to write? First we have to write as limit n tends to infinity 1 by n plus 1 plus 1 by n plus 2 plus and so on 1 by 6n. That is the given information. N plus 1, n plus 2 and so on is there. 6n can be written as n plus 5n, no? According to this, n plus 1, n plus 2 and so on. 6n can be written as in terms of n plus 5n. In the next step, limit n tends to infinity 1 by n plus 1 plus 1 by n plus 2 plus and so on 1 by n plus 5n. I hope everyone understand. Later on, what we have to do is, generally after limit n tends to infinity we need to get 1 by n, no? But here 1 by n is not there. We want to get it. From here n take out common. From here, here, here. So observe carefully is the step, dear students. Limit n tends to infinity 1 by n into 1 plus 1 by n. Am I right? Plus 1 by n take out common 1 plus 2 by n plus and so on 1 by n take common 1 plus 5 by 1, 5n by 1. For n by n also we can write. N get cancelled, 5n only will come. Everyone understand? So 1 by n, 1 by n, 1 by n. Once again I repeat here, n we are taking common. If we take out common n, 1 plus 5 only will come generally. But I want to get 1 by n, 2 by n and so on. Here last 5n is there, no? 5 by n I want to get. So 1 by n take common from all the terms. Limit n tends to infinity. Here 1 by n, here 1 by n, here 1 by n. 1 by n take out. So the remaining is 1 plus 1 by n plus 1 by 1 plus 2 by n plus and so on 1 by 1 plus 5n by n. This you have to write in terms of sigma. So limit n tends to infinity 1 by n, sigma I is equal to 1. Here 1 by n, 2 by n means n is equal to, I is equal to 1. I is equal to 1 to where? 5n. You remember, dear students, that is the difference between this problem and this problem. So I is equal to 1 to 5n, 1 by 1 plus I by n. After writing this summation, we need to write the values. I by n is equal to x. Wherever I by n is there, x. Wherever 1 by n is there, it will become dx. And find out lower limit and upper limit. In place of limit n tends to infinity, sigma I is equal to 1 to 5n. That value is integral 0 to, like upper limit to lower limit to upper limit. Lower limit is what? Limit n tends to infinity. Initial value of I is what? 1. By total number of values are n. So 1 by n. Limit n tends to infinity, 1 by n is what? 0. Similarly, upper limit n tends to infinity. Total values of n is number of divisions n. What is the final value of I? I is equal to 5n. Here n get cancelled. Limit n tends to infinity, 5 constant is what? 5. So lower limit is 0, upper limit is 5. So come to this integral. In place of limit n tends to infinity, sigma I equal to 1 to 5n, we replace with integration. Integral, lower limit is 0, upper limit is 5. In place of 1 by n dx, in place of I by n x, so 1 by 1 plus x. Is it clear? Integral 1 by x, log mod x, so which is equal to log mod 1 plus x, applying the limits 0 to 5. So first, in place of x, upper limit log 1 plus 5 minus lower limit log 1 plus 0. So which is equal to log 6 minus log 1, log a minus log b, log a by b, log 6 by 1, that is equal to log 6. Therefore, in limit n tends to infinity, 1 by n plus 1 plus 1 by n plus 2 and so on, 1 by 6 are equal to log 6 or log 6 to the base e. We will move on to the next question. The next question, dear students. Evaluate limit n tends to infinity 1 by n tan pi by 4n plus 4x, dear students, it is not 4n, 4x. Here also 4x. Tan pi by 4x plus tan 2 pi by 4x plus and so on tan n pi by 4x. Once again, I will check that question. The question is correct only, dear students. Evaluate limit n tends to infinity 1 by n into tan pi by 4n plus tan 2 pi by 4n plus and so on tan n pi by 4n. 1 by n, it is already there. So, limit n tends to infinity 1 by n into tan pi by 4n plus tan 2 pi by 4n plus and so on tan n pi by 4n. Here 1 into pi by 4n, 2 into pi by 4n and so on n into pi by. So we can write sigma now. Limit n tends to infinity 1 by n sigma I equal to 1 to n, I is equal to 1 to n, tan of I by n into pi by 4. Observe carefully, dear students. See, I is equal to 1 if you substitute 1 into pi by 4n. I is equal to 2, substitute 2 pi by 4n. I is equal to 3. I is equal to n, substitute n pi by 4n. Am I right? After getting these values, what we have to do? Generally, I by n is equal to x. Wherever 1 by n is there, dx. Find out upper limit and lower limit. Lower limit first. Limit n tends to infinity. Total number is n. Initial value of I, 1. Limit n tends to infinity, 1 by n value is what? 0. Limit n tends to infinity. Total values are n. What is the final value of n? I. Final value of I is n. N by n is equal to 1. So limit of constant is constant. So this will becomes, in place of limit n tends to infinity, sigma I equal to 1 to n. Replace with integral 0 to 1, upper limit to lower limit. So lower limit to upper limit. In place of 1 by n, dx. In place of I by n, x. So tan I by n value x. So pi by 4 x. We have formula in integration. Integral tan ax dx is equal to log mod secant ax by x coefficient is a, no? So 1 by a will come plus c. So whatever x coefficient is there, that value. Here also x coefficient pi by 4 now. So integral 0 to 1 tan pi by 4 x. Integral tan x is log mod. So log mod secant of pi by 4 x by pi by 4. It will be 4 by pi. Applying the limits 0 to 1. First x is equal to 1, substitute 4 by pi log secant pi by 4 minus log secant 0. So secant pi by 4, it is root 2. 4 by pi log secant pi by 4. Cos pi by 4 means 1 by root 2. Secant pi by 4 means root 2. Root 2 minus secant 0 is 1. Log a minus log b. Log a by b. So 4 by pi log root 2 by 1. So which is equal to 4 by pi log root 2. Root 2 means what? 2 power 1 by 2 only. So that also equal to 4 by pi log 2 power 1 by 2. That 1 by 2 also will becomes log a power m formula. Log a power m equal to m into log a. Logarithm properties. So 4 by pi into 1 by 2 log 2. So 2 ones, 2 2s. So which is equal to 2 by pi into log 2. So this is the value of given limit. Now come to the next question here. Limit n tends to infinity, sigma I equal to 1 to n, I power cube by I power 3 by I power n plus n power 4. This form it is given directly, sigma. But 1 by n is not there. I want to get 1 by n. How to get is, in the numerator the power is 3, in the denominator the power is 4. So dividing numerator and denominator by n power 4. N power 4. See here how it will be is, limit n tends to infinity. I want to get 1 by n, no? So to get 1 by n, sigma I is equal to 1 to n, I power 3 divided by n power 4 whole divided by I power 4 by n power 4 plus n power 4 divided by n power 4. I hope everyone understand. Highest power of this value dividing. Here I cube by n power 4 is there, no? In the next step, 1 by n into I power 3 by n power 3 I am going to write. So limit n tends to infinity, sigma I is equal to 1 to n. This can be written as 1 by n, I cube by n cube, that is I by n whole cube, divided by I by n whole power 4 plus 1, n power 4 by n power 4. This 1 by n we can take here, limit n tends to infinity, 1 by n, sigma I equal to 1 to n, I by n whole power 3 divided by I by n whole power 4 plus 1. Later on what we have to do that? Common procedure. Let I by n is equal to x and 1 by n is equal to dx. Find out lower limit now. Limit n tends to infinity. N in the denominator, total number of partitions. What is the initial value of I? 1. Limit n tends to infinity, 1 by n value goes to be 0. Upper limit, when limit n tends to infinity, total number of partitions are n and final value of I is n. So n by n is equal to 1. So now in place of 1 by n dx, in place of these two, integral 0 to 1 by n value dx, I by n value is what? X, x power 3 by x power 4 plus 1. For this, 1 plus x power 4 derivative is what? Here, if you take f of x is equal to x power 4 plus 1, differentiate with respect to x. F of x derivative is what? F dash of x, 4x, x power 4 derivative 4x cube. But 4x cube is not there in this. So what I am doing is multiplying and dividing by 1 minute students. Multiplying and dividing by 4 for this. So in the next step, integral 0 to 1, here dividing by 4, here multiplying by 4. By x power 4 plus 1. So what for you are doing like this? If you do like this integral is of the form integral f dash of x by f of x into dx. That means log mod f of x. This formula we are going to apply. So now 1 by 4 log mod f dash of x by f of x. So x power 4 plus 1, applying the limits 0 to 1. So 1 by 4 log 1 power 4 is 1 plus 1 minus log 0 plus 1. So which is equal to 1 by 4 into log 2 minus log 1. Log a minus log b, log a by b. So 1 by 4 log 2. So log 2 by 1 is log 2 only, no? 1 by 4 log 2. So this is the required value. We'll move on to the next question, dear students. The next question, dear students. Evaluate limit n tends to infinity sigma I equal to 1 to n I by n square plus I square. This is like last problem, question number 11. Here also I want to get 1 by n. Here 1 by n term is missing. Sorry. I want to get I by n value here. So in the denominator the power is 2, in the numerator the power is 1. So dividing numerator and denominator by n square. See here, first limit n tends to infinity sigma I is equal to 1 to n, I by n square, first given, you write it, later step you will write it, n square plus I square. Here what I am doing is, limit n tends to infinity, I by n square by n square by n square plus I square by n square. I by n square can be written as 1 by n into I by n. Limit n tends to infinity, I by n into 1 by n divided by, here n square by n square is 1 plus I by n whole square, we can write it. In the next step, 1 by n I am taking this side, sigma I forgot, no, sorry. I is equal to 1 to n. So limit n tends to infinity, this 1 by n I am taking outside of the sigma, and sigma I is equal to 1 to n, I by n by 1 plus I by n whole square. After that, what we have to do, our duty is, wherever I by n is there, x, 1 by n is there, dx. So find out lower limit and upper limit. Lower limit, limit n tends to infinity, total parts n denominator. So initial value of I, 1. Limit n tends to infinity, 1 by n value goes to be 0. Limit n tends to infinity, total value is n. Final value of I is n. So in place of limit n tends to infinity, sigma I equal to 1 to n, we have to replace with integral 0 to 1, lower limit to upper limit. 1 by n value goes to be dx. So 1 I by n value, x divided by 1 plus x square into dx. Wherever I by n is there, replace with x. Even here also, like previous problem, whose derivative 1 plus x square derivative is what? 2x. Here I am mentioning f of x is equal to 1 plus x square. Differentiate with respect to x. F dash of x equal to 2x. So 2x is not there. In the next step, multiplying and dividing by 2, integral 0 to 1, 2x by 1 plus x squared into dx. F dash of x by f of x into dx, log mod f of x. So 1 by 2, in the previous question I wrote, but still those who are, integral f dash of x by f of x into dx is equal to log mod f of x. Generally plus you are right, but this is a definite integration, no? That is the reason I am not writing. Log 1 plus x square, applying the limit 0 to 1. So half into log 1 plus 1 square, 1 square means 1, minus log 1 plus 0. So that is equal to 1 by 2 log 2 minus log 1. So log a minus log b, log a by b. 1 by 2 log 2 by 1. So half into log 2. Even this is also correct answer. But if you want to write 1 by 2 as a power, log 2 power 1 by 2, that is equal to log root 2. All answers are correct, dear students. So the given limit n tends to infinity, sigma I equal to 1 to n. I by n square plus I square value is log root 2 or half log 2. We'll move on to the question number 13. Here also 1 by n is not there, sigma also not there. We will make it. Limit n tends to infinity. 1 means what? 1 power n only, 1 power 4 only, plus 2 power 4, plus 3 power 4, plus and so on n power 4, by n power 5 can be written as n into n power 4. So this n we can take outside. Limit n tends to infinity. 1 by n. The rest of the terms 1 power 4 by n power 4. So 1 by n whole power 4 plus 2 power 4 by n power 4. That means 2 by n whole power 4 plus 3 by n whole power 4 plus and so on n by n whole power 4. After that I want to write sigma. So limit n tends to infinity 1 by n, sigma I is equal to 1 to n, I by n whole power 4. I is equal to 1, 1 by n whole power 4 plus I is equal to 2, 2 by n whole power 4 plus I is equal to 3, 3 by n whole power 4 plus and so on. After that, wherever I by n is there, what you have to write? I by n is equal to x, 1 by n is equal to dx. So, lower limit and upper limit. Limit n tends to infinity, total number of partitions are n, initial value of I is 1. So, limit n tends to infinity, 1 by n tends to 0. Upper limit, limit n tends to infinity, total partitions n, and how many partitions are there total? N. I is equal to, that means final value of I. Limit of any constant is constant. So therefore, integral, it will becomes, in place of limit n tends to infinity sigma value, integration, lower limit to upper limit, and in place of I by n, x, 1 by n as dx. So x power 4 dx. Integral x power 4, x power 5 by 5. Applying the limit 0 to 1. So 1 power 5 by 5 minus 0. So that is equal to 1 by 5 minus 0. So we will move on to the question number 14. I hope everyone understand that. Still any doubts are there, please write to my comment box. I will help you. The next question. Limit n tends to infinity 1 plus 1 by n square into 1 plus 2 square by n square plus and so on 1 plus n square by n square whole power 1 by n. I already discussed in the first video, dear students. Whenever whole power 1 by n is there, the given limit we can take as p. So first let p equal to limit n tends to infinity 1 plus 1 by n square into 1 plus 2 square by n square into and so on 1 plus n square by n square whole power 1 by n. Taking log on both sides. Taking log on both sides. So it will become log p, that is equal to, log means log to the base c always. So log of this value, log limit n tends to infinity 1 plus 1 by n square, 1 plus 2 square by n square, and so on 1 plus n square by n square. So log a power m, m into log a. So it will becomes 1 by n log limit n tends to infinity. Here we will make it here only 1 plus 1 by n square. That means 1 means 1 square you can write now. 1 plus 2 square by n square and so on 1 plus n square by n square. Can we write like this? Sigma I is equal to 1 to n 1 plus I by n whole square. Am I right? After that, what we have to write is, this 1 by n we are taking inside the log and limit we can take outside of the log. So we can take it as limit n tends to infinity 1 by n, this sigma also, I is equal to 1 to n, log of 1 plus I by n whole square. Sir, how it is correct, sir? I is equal to 1, substitute 1 by n, 1 square by n square. So log of, next I is equal to 1 to 2. Log, here the product is there, no? The value sigma is plus log 1 plus I by n, that means 1 by n whole square, plus log 1 plus 2 by n whole square, plus and so on. Log a plus log b plus log c means log into abc only, no? So log into abc, product only, no, we are getting. That's why like this we can write, there is no changing the meaning. After that we know that the procedure of this one, wherever I by n is there, what we have to write? X. 1 by n is there, dx. Finding lower limit and upper limit. Limit n tends to infinity. Lower limit is initial value of I, 1. Total values of n is 1, 1, 2. Limit n tends to infinity, 1 by n value goes to be 0. Upper limit, limit n tends to infinity. Total partitions of interval is n and final value of I, n. So this will becomes, wherever 1 by n is there, dx. Limit and this sigma will become integration 0 to 1, lower limit to upper limit. And log of 1 plus x square into dx. Here we are going to apply integration by parts, dear students. This is log p to the base e. By using integration by parts, integration by parts formula, you know that. Whenever log function is there, into 1 we can write, that is g of x. Integral 0 to 1 log of 1 plus x square into 1 into dx. This is f of x, this is g of x, dear students. Integration by parts formula, for your convenience I am writing here. Integral a to b f into g dx equal to f into integral g dx, applying the limits a to b, minus integral a to b f dash into integral g of x dx whole dx. So this is the formula I am going to apply here. So which is equal to log of 1 plus x square into integral 1 into dx. Integral 1 into dx, applying the limits 0 to 1, minus integral 0 to 1 f dash of x, log 1 plus x square derivative. 1 by 1 plus x square, again x square derivative is 2x. Log of 1 plus x square derivative, 1 by 1 plus x square, again 1 plus x square derivative 2x, into integral dx whole dx. So that is equal to log 1 plus x square, integral dx is x, applying the limit 0 to 1, minus integral 0 to 1, 2 constant we can take aside, x by 1 plus x square into integral dx is x whole dx. That is equal to, first upper limits x is equal to 1, substituting log 1 plus 1 into 1 minus 0. X is equal to 0, substitute 0 into everything is 0. Minus 2 into integral 0 to 1 x square by 1 plus x square into dx. Later on, this limit will becomes log p to the base e equal to, this value is log 2, that means log 2 to the base e, minus 2 into integral 0 to 1. Here x square is there, here 1 plus x square is there. So I want to convert the numerator in terms of denominator. Adding plus 1, subtracting minus 1. X square plus 1 minus 1 by x square plus 1 into dx. So the log 2 to the base e also we can take this side. Log p to the base e minus log 2 to the base e is equal to minus 2 into integral 0 to 1 x square plus 1 by x square plus 1 into dx. Minus into minus is plus. 2 into integral 0 to 1, 1 by 1 plus x square into dx. These two will be cancelled. I hope everyone understand. Log a minus log b, log a by b, log p by 2 to the base e is equal to minus 2 into integral dx. Integral 0 to 1 into dx plus 2 into integral 0 to 1, 1 by 1 plus x square. Integral 1 by 1 plus x square is tan inverse x. Applying the limit 0 to 1. So minus 2 into integral dx is x, applying the limit 0 to 1, plus 2 into tan inverse of 1 minus tan inverse of 0. That is equal to minus 2 into 1 minus 0 plus 2 into tan inverse 1 is pi by 4 minus tan inverse 0 is 0. So log of p by 2 to the base e is equal to minus 2 plus this will become pi by 2, 2 ones, 2 2's. If you simplify this 2 to the 4, pi minus 4 by 2. So log of p by 2 to the base e. If you want to remove log, so p by 2 equal to, so exponential e power of pi by 4 minus 2. But I want p value. So therefore p equal to, so 2 we are taking this side, 2 into e power pi minus 4 divided by 2. That is, what is p? We assume that limit n tends to infinity. 1 plus 1 by n square, 1 plus 2 square by n square, and so on, 1 plus n square by n square is whole power 1 by n is equal to 2 into e power pi minus 4 divided by 2. This is the way we can do this, students. This is a very important whole power 1 by n type questions we may expect in MCET mains. So of course it is little lengthy. For your understanding purpose I am explaining clearly. We'll move on to the next question and last question in this exercise. Next question, question number 15. Evaluate limit n tends to infinity n factorial whole power 1 by n by n. So whenever whole power 1 by n is there, we need to apply log on both sides. So before that, what we have to do, dear students, in the numerator is having power 1 by n, but denominator is not there. But we will make it like this. Limit n tends to infinity, n factorial divided by n can be written as n power n whole power 1 by n. Meaning cannot be changed once you check this. N factorial whole power 1 by n, numerator comes. N power n by whole power 1 by n get cancelled, n only will. So meaning cannot be changed. So taking log on both sides. So whenever log we are taking like log of limit n tends to infinity n factorial by n power n whole power 1 by n. In the next step onwards. So log p to the base e is equal to, that 1 by n will come here, log of limit n tends to infinity n factorial by n power n. So log p to the base e 1 by n log of limit n tends to infinity. N factorial means 1 into 2 into 3 into 4 into and so on. N factorial means the product of n terms by n power n. So n into and so on n times. So n into and so on n times. Let it be written as, observe dear students, 1 by n log of limit n tends to infinity Can we write like this? 1 by n into 1, 2 by n, 3 by n, and so on n by n. So this I am going to write as a sigma 1 by n log of limit n tends to infinity sigma I equal to 1 to n I by n. Later on, log we are taking inside the bracket, limit n tends to infinity we are taking outside. So it will becomes limit n tends to infinity 1 by n log inside sigma I equal to 1 to n log of I by n. Now you can check that. I is equal to 1, substitute log 1 by 1 by n. I is equal to 2, 2 by n. Log I 3 by n. Log a plus log a. Here sigma is plus no? Log 1 by n plus log 2 by n plus log 3 by n plus and so on log n by n. Log a plus log b plus log c means log abc. So that is the product. Both are same. I hope you understand. So now, wherever I by n is there, what you have to write? I by n is equal to x. 1 by n is equal to dx. Find out upper limit and lower limit. First lower limit. Limit n tends to infinity. Total number of divisions are n. Initial value of I is 1. So limit n tends to infinity, 1 by n goes to be 0. Upper limit. Limit n tends to infinity. Total partitions of n is n. And final value of I is n. N by n is constant. Limit n tends to infinity, constant is constant. So integral 0 to 1 in place of limit n tends to infinity sigma 1 by n value as dx. So log of I by n value x into dx. Integral log x. So whenever we are integrating log x, integral 0 to 1 log x into 1 into dx. Here integration by parts. This is f, this is g. Integration by parts formula, integral f g into dx is equal to, that also a to b formula. F into integral g, applying the limits a to b, minus integral f dash of integral a to b, f dash into integral g into dx, whole dx. This formula we are going to apply by using integration by parts. So now, log p to the base e is equal to, here f means what? Log x into integral g, integral 1 into dx, applying the limit 0 to 1, minus integral f dash of x 0 to 1, log x derivative is 1 by x, integral 1 into dx, whole dx. So log x into integral dx is x, applying the limit 0 to 1. Integral 0 to 1, 1 by x into integral dx is x. So x is equal to 1, substitute log 1 into 1 minus 0. Anyway, log 1 value also 0, this complete term goes to be 0, minus integral 0 to 1 into dx. So this is 0 minus integral dx is x, applying the limit 0 to 1. So 0 minus 1 minus 0. So ultimately minus 1. Log p to the base e is equal to minus 1. P equal to e power minus 1. That is p equal to e power minus 1 means what? 1 by e. Therefore p means what? Limit n tends to infinity n factorial whole power 1 by n divided by n is equal to 1 by e, that is equal to e power minus 1. Thank you dear students for watching our channel Maths with Panindra. Please do subscribe to Maths with Panindra. If you like really this video, please share to needy students. Thank you all. Jai Hind. Still any doubts are there, please write to comment box. I will help you in my free time. Thank you all.